Today we'll try to achieve the objective of vulnerability analysis of wetlands under changed climate scenarios with the help of water cycle and polynomial networks. So here what we'll do is we'll try to analyze the vulnerability faced by the wetlands under different climate change scenarios. There are two objectives we want to achieve. One is, first objective is to find the optimal ratio of different dependent factors which enhance or reduce vulnerability of wetlands. Some factors will increase the vulnerability, some factors will decrease the vulnerability. Like for example, if there is a wetland and if I increase depth, then more water can be accumulated, so more fresh water can be accumulated, which will actually reduce the vulnerability. On the contrary, if the BOD content, biological oxygen demand content of the water of the wetland is increased rapidly, then that water of wetland cannot be consumed for drinking. And also the freshness of the water will slowly but steadily reduce. So that will actually increase the vulnerability of wetlands. So that type of factors can be considered as vulnerability enhancing factors or risk enhancing factors. So my first objective is to find the optimal ratio between the reliability enhancing and risk enhancing factors of wetland. And with the help of that, what we can achieve is if we can find the optimal VAF, then we can compare the normal VAF or the current VAF. Here VAF is actually the vulnerability assessment function. So VAF optimal, if compared with VAF current or present, whatever you may say, or if VAF optimal is compared with the VAF future, what this VAF can be calculated based on the different scenarios of climate change as prescribed in the representative concentration pathways RCP and its different sub-scenarios. So we can actually compare the VAF of the present scenario and also the VAF of the future climate change scenarios and compare those with the VAF optimal. And we can identify, or we can tangibly analyze how much that wetland can be vulnerable or how much the wetland is vulnerable compared to its optimal status. So that is our one objective, and second objective is to find the VAF of future climatic scenario and as well as the current climatic scenario, such that we can analyze how much impact of climate change will be there into the wetlands. So basically VAF we are creating as the medium of representing the impact of climate change on the wetlands. So prerequisite is these two very important algorithm. Water cycle algorithm, this is the YouTube link. And also you can scan the QR code and go straight to that video. And this is the Polynomial Network algorithm tutorial of that. So you can scan this QR code and straight away go to the video. Remember, Polynomial Neural Network or GMDH is actually not the same thing. GMDH, group method of data handling, is a software which actually use the PNN functionalities or PNN logic to develop different types of neural network based models. And how to do that thing is described in this video. So, and the basic introduction on water cycle algorithm is given in this video. Both of these are important. Yeah, so vulnerability assessment function, this is actually we are referring as VAF. How to develop that vulnerability assessment function of wetlands. So by discussing or referring to different literatures and stakeholders, we can identify the most significant factors of wetlands. And then we can separate these factors into two groups. As I was discussing earlier, reliability enhancing factors and risk enhancing factors. So capital R is representing the value of the reliability enhancing factors and small r is representing the values of the risk enhancing factor. Value means this R, that it be R can be our reliability means depth, whereas small r can be the concentration of POV. So when these factors are identified, try to find out the weightage of importance of each factors for each group with respect to the impact of climate change. So you can use analytical hierarchy process multi-criteria decision making method to achieve this. And in case of HPMCDM, I will share the link tutorial to that AHP in the description of this video. So what in case of AHP, you need criteria, you need alternatives. Here what you will do is you take the climatic variables like rainfall, where there is icefall also present, there you take precipitation, and evapotranspiration as the criteria, and these all the factors, reliability enhancing factor as the alternative. So once you determine the weightage of all the reliability enhancing factors in this manner, then again apply the HP in the same way, but this time for the risk enhancing factors. So basically, you find the weightage for reliability enhancing factor in one step, and in another step, again you apply AHP to find the weightage of the risk enhancing factors. Don't do it by mixing all the factors from the two groups. One group at a time. So once you have done that, place the reliability enhancing factor in the numerator and the risk enhancing factor in the denominator. After multiplying them with their weightage and summing all of them into one value. Okay, so this is the equation. You see, this is the summation sign, and this WR is the weight of the R's. Each R has its own weightage. Multiply both of them. R is of course the value of that factor magnitude, and then you add them. So for reliability, you place this function in the numerator, and for risk, you place them in the denominator. So such that when reliability factors increase, V increases. When risk enhancing factors increase, V decreases, and vice versa. If that is the case, then VAF, the vulnerability assessment function, will be e to the power, that is the exponential 2 or exponential of V, e to the value. The reason for using this e is to make the this V more pronounced, more clear. So next comes this optimization technique is applied to find the optimal ratio of all the risk as well as reliability enhancing factor. That means this is the VAF at which your risk will be minimum and reliability will be maximum. That means vulnerability will be minimum. So for that you can convert all the values of the reliability factors and risk enhancing factors to 0 and 1. To its normalized part. So this is done to remove the scale impact and also to make it dimensionless. Okay. So after doing this, we will optimize this VAF. Here we will consider VAF as the objective function, and all the design variables, all the values of this factors are reliability enhancing factor and as well as smaller as the design variables. And by changing these design variables, we will try to maximize VAF. As all the reliability enhancing factors are in numerator, so VAF is directly proportional to reliability enhancing factor, but inversely proportional to risk enhancing factors. Remember, our goal is to find the optimal VAF with which we will compare the current VAF or the future climatic VAF to find the actual level of vulnerability of a wetland. Okay, so here the optimization techniques will be the water cycle algorithm and polynomial neural network, and both the algorithm will maximize the equation objective function, and both will give you two different maximum values of VAF. So you will go with that VAF which is higher to the other VAF. That means VAF of algorithm 1 must be greater than VAF of algorithm 2 to be selected as the optimal VAF. Okay, and as you know, in case of optimization technique, there are also constraints. So if you convert all the reliability factor and risk enhancing factor into normalized value, then 0 and 1 will be the lower and upper constraint of the variables respectively. But if you do not normalize, then the minimum value possible for the factor will be the lower constraint, and the maximum value possible for the factor is the higher constraint. Okay, but it is always better to normalize the variables to remove the scale impact or this dimension impacts. So this is the way. So you, after optimization, you will get the optimal VAF, and from optimal VAF you will know the value of the corresponding factors at which this VAF is maximum, and if you can keep your factors at those values, then your VAF will be maximum. Okay, so actually this maximized VAF or optimal VAF is giving you a goal or a threshold or a median to represent the degree of vulnerability of the current status of the wetlands. So whenever you are comparing this VAF optimal with the VAF current or VAF future, then what you are doing is you are actually getting the level of vulnerability this wetland is there. If the current VAF is more than the optimal VAF, then this wetland is not vulnerable at all. But if it is very low, very lower compared to this optimal VAF, then it is under stress or it is under severe vulnerability. If the optimal VAF and current VAF has a difference of suppose 100%, that means VAF optimal is 100% more compared to VAF current, then your VAF or your wetland is currently 100% vulnerable, very severely vulnerable. Okay, so that is what we are to achieve. And the reason for using water cycle and polynomial neural network is neural network is used due to its adaptability and flexibility, and water cycle algorithm is used because of a very minimum number of parameters that we have to estimate. Also, the number of iteration is very less, it has a very fast convergence rate, water cycle algorithm, due to its specific preventive measurement or preventive measures to avoid local minima. But you can of course use any type of algorithm. You can use glowworm, you can use firefly, you can use genetic, you can use particle swarm optimization, any type of algorithm you can use. But after our study is completed, we can surely tell in between water cycle and polynomial which one is giving the better VAF. So this is what we have to do. So with this I will finish. I have given an idea of the project objective, how to achieve it, benefit also, because by this we are proposing a optimal VAF, an optimal media, or we are giving a reference frame to identify the degree of vulnerability of our wetlands. So presently all the vulnerability analysis methods are absolute methods. They do not give you any reference frame. But this method will be the first of its kind, which is giving you a relative vulnerability. So thank you, and I will close for now. If you want to know more about optimization technique, or only about optimization technique, because if you do not know about optimization technique, you will not know what is objective equation, what is our design values, what is constraint, what is the optimization technique. All these things will be Hebrew to you. So I am also adding the link to my lecture on optimization technique in the description of this video. So 2 links in the description, one for AHPM CTM, one for optimization technique. Regarding the working principle of water cycle and polynomial neural network, that is the GmbH, that is already shared in this video by the QR code as well as the link to those YouTube videos. So go through it and try to achieve this objective. Thank you.